Okay, hello guys, welcome to lecture 14 this week. Today we are going to have our object-oriented programming extended topic. Last time we have talked about basic concepts and how to implement a single class in Python OOP. And we usually have, like say you want to implement the PVC game, and then you want to implement the class of plant or the class of zodiac, zombie. So this lecture, we are going to talk further about how to actually create classes based on other classes. So we will talk about um, so the first one we will talk about inheritance and then polymorphism. They are basically very similar, and they are consisting of how you actually create a class based on other classes, and then what are the strings and representation, and how to use f string. So let's talk about the first one, inheritance. So like inheritance, in biology, inheritance usually means that like children, they actually will inherit some of the characters, like for example they look like the same from their parents, uh or maybe they have similar behavior of their parents. They will inherit some same features or maybe characters of their parents, but they also have slightly different from their parents. Inheritance is like the the part that like the children will inherit some same features of their parents. Like for example, like we have a cat, and this cat gave birth to, let's say, six catties, and then they actually look like the same. Like you see, well, usually they have white feather, and their eyes are also black, and then some kind of yellow around, and they also have red ears or something. They are like the children are actually inheriting the features of their parents. This is called like similarity, and we call that in programming, call that like inheritance. Like for example, if you say another example about is like when you read Harry Potter, and like people usually say, oh, Harry has the same eyes as his mom, and he actually looks like very similar to his father though. Like so Harry inherits some very similar features from his parents. So how to kind of doing that in programming? So let's say we actually created some class, like we have plant and we have zombie, and they are having very distinct behaviors. But let's say if you want to go deeper into the plant, you may have other uh, many kinds of plants. They are all in the group of plants, but they are many different kinds. Like they are plants. Like the basic is that they are plant, but some plants can kind of behave different from other plants. For example, the sunflower can actually produce sunlight, and then yeah, produce sunlight. But some of them like um, they have to create some other stuff, kind of like creating bullets so that they can attack the zombies. Well, in OOP, some classes can copy some features from a class, develop some different attributes and behaviors upon their parents, but they will still have the same attributes and functions, same as their parents. So it's like Harry like has same eyes as his mom and mother and something like that. So the class that inherits from another class is called child class. Like the class is inheriting some properties, like copying some properties from another class. And the class that is copying from other is called child class. And the class being copied is called the parent class. So yeah, it's more like parent frame, children frame, and you have something in parent frame, and you also have something in children frame. Yeah, so it's basically have the relationship like this formulated. Yeah. So back into PVC. So we have talked about like we have some different plants in the group of plants. Like we have sunflowers, we have kind of pea, and also um, potato. They are having actually different behaviors, although they are all plants. But the basic of them is like they are plants though. So they have everything that a plant should have to be a plant, such as they cannot move, and they also have something like called health, like how long they can like resist to be attacked and things like that. Yeah. So suppose I already have the class plant, and if I want to create the class called sunflower, do I have to copy all of this from this plant? This plant class? No, we don't. We don't have to. Instead, we can do inheritance. We can uh, inherit from plant class into the class of sunflower, so that the everything including the function and the attributes inside the plant class will also be the attributes and also the member functions of the new class, the class of sunflower. But the thing is that we have to include um, the class where we want to inherit from. So we have class sunflower, and we have parentheses, and then we have the parent that we want to inherit from. So the plant is the parent class, so that we want to inherit um, from parent and copy the stuff, all the stuff from parent, from the plant class into the sunflower. So we also have sunflower and the same thing, initial self.health. There's we can also do our initialization. Yeah, so it's like that. So we have class and the name of the plant, and we have to write down in the parentheses what the class we want to inherit from. So the name of the class, and also with a set of parentheses. Inside the parentheses, you want to say, oh, what is the parent class of this class? Like, obviously this class is a child class, and you want to find out who is their parents. So you want to set the parent parentheses and including their parent. So for the class sunflower, it first inherit all the stuff from the plant. And then once you say sunflower, you want to initialize, they have the same attribute and um, have the same attributes and member functions as in the plant class. So this is before polymorphism though. Like this is inheritance. Like we're talking about the concept inheritance, like copying the features, copying the member functions and attributes, and then put it into new class so that you don't have to overwrite the same codes inside this new class. We don't have to write down all the stuff from the plant class again. I we just copy that automatically if you say a parenthesis with a parent inside. Yeah. So we will talk about polymorphism. Polymorphism is like when you do inheritance, you basically just having the same features, uh, have the same features from the parents, but you may be slightly different from your parents. Like we will call like somehow like something changed. Like you are not um you are not copying all of the stuff from the parents. Like for example, for the cat, like remember the cat photo, like we have actually a cat that is like different from his mother. Like for example, this cat, like having not just white, um, but other colors like gray, brown, and other stuff. you might say like at the first sight, this can might not be the child of this mother, but he is though. But he is. The thing is that when he's doing inheritance, he's like making some small changes so that he can be distinct with their parents, so they can do like having some other behaviors, other attributes that their parents um, don't have. So yeah, and also back to let's say Harry Potter example, um, like Harry Potter can speak to Snake, I guess. Yeah, I read that. And but their parent the but Harry Potter's parents they don't speak with Snake because Harry is in like having other features that have nothing to do with their parents. So this makes Harry different from their parent different from his parents. So yeah, so we are also having some different attributes and member functions. When you copy all the stuff, when you're doing inheritance, you're copying all the stuff from your parents' class. But you can make some changes upon that though. You can add something, and you can change something like maybe you are doing something like um, maybe you are having the same member function, but you can make some small changes in this member function so that although we are calling this function, but due to different object, like this function in one flower, one kind of flower is different from that one from the rest of the flowers. And when you call the function with the same name, it may not have the same behavior. So this polymorphism. Yeah. So polymorphism is we can check that word. Poly means technologically, and morphism is like a kind of structure. Like we are having technically some technology structures that are kind of different uh, from from other peers in your age, in your group or something. Yeah. So this is polymorphism. Inheritance is like copying the stuff from your parent. Polymorphism is like make some changes upon the stuff that you copied from your parent. So yeah, and also in the code, children can have the same function names from their parents, but you may have some different behaviors. You can make some changes inside the function by like copying the name again and doing something new inside, and then yeah, polymorphism. I guess when I took the 61A class, they speak overriding more than polymorphism. They're like overriding means you want to like there's something out there, but you want to uh, like for example, you have something out there, and then you want to make it different. So you want to put something above this thing, like it's like over the old stuff. So it's called overriding, I guess. But at DVC, the professor said it's called polymorphism. Yeah, polymorphism. I guess is specifically talking about this kind of features in Python OOP. So yeah. Um, we back to the plant. So suppose I have an attribute can move is false, and then I have the initial function, I have health, I have a power, and then I receive some like remember in the plant game, like when you receive some, you can make some more plants, I guess. Yeah. So suppose I have a kind of plant called potato. Do you remember like what potatoes do in this game? They do nothing. They just stand there and then uh, I guess they just play a role as a wall. And the zombies just go to this potato and eat the potato until the zombie finish eating so that zombie can move forward. Potato is like doing nothing but standing there, bare being bite or something. Yeah, so it helps stop the zombie for a while. So let's see what we implement potato. Like since we have inherit all the stuff automatically from the class of plant. So if you now have nothing here, you just call potato and then dog can move, you return false though. Yeah, but I want to do something different. So for initial function, I have health, but I don't have power. Do you remember like in potato, because potatoes do not attack any zombies, so it will not have power. Oh, I forgot to talk about what power is. A power is like when you attack the zombie at once, how much harms you cause onto the zombie. Like suppose the zombie has health of 2, and is your prime power is that 1 or 2? If that's 1, you have to attack the zombie twice so that the zombie can die. And otherwise, like if your power is 2, and then you only have to attack the zombie once, so the zombie can die. So yeah, the power. But for potatoes do not attack zombies. So I can say in the initial function, it will not have the power. Like it's unnecessary though. So and also define, yeah, receive some and like self sum, and then I make the health self the health become solution, and solution is some mod 6, and this is mod 5. Well, I'm not sure what that do though, but I guess it's just how to recover potato or just make a new potato, like by using how many suns. Yeah, so you just say it's an action of receiving sun, and then like suppose I have the same functions here, like oh, I have the functions with the same names as in the parent frame, but they are acting differently. So when I say when I say potato, suppose it's an instance of this class. So potato dog receive some. Yeah. So I guess let's say 30. Yeah. Yeah. And then you have so and also another kind of, let's say just sunflower dog receive some 30. When you are doing this, although you have the same names, but when you call this, it will go into this potato class and then check out, oh, you have a received some and it's mod 6. So potato health would be increased by 5 away. 6 is like, oh, let's change it into 10. Change it into 10. So the sun will be wait, 10 mod 6, I guess, is 4. Yeah. So the health will be increased by 4. But for sunflower, the health will be increased by 0. Yeah. Because it's mod 5. Yeah. Like they are having the same names, but for potato, if you want to like if you don't want to modify this function, you don't have to create the function with the same name, uh but you want to make a change. So you implement this again by having some changes inside of it. And next time you call this function, a potato calls this function, it will go into here, and then you will initialize this line. Yeah, it will execute this line. So it's acting different than other plants. Yeah. So and also the function have the same name but different results. Also sunflower. Let's see, what's different of this. So yeah, so for sunflower, we have talked about changing existing functions, but we haven't talked about creating a new function. So you can do comparison of these two. Like for the prime function, for the prime class, it does not have the behavior called collection, because usually as a prime you don't collect sums. So, but for sunflower, this is what it should be doing. Like this is attributes, I guess, like only belongs to it. So for collection, that does not exist in the old class, but you can implement it in this sunflower class by just adding a new function. So collection self and sun plus equal 25. So the function in the child class can also be new to parent, like it can be brand new, Um, yeah. So, so this is polymorphism. We have two types of polymorphism. One is making changes in the old existing functions. One is adding new functions into the child class. Yeah. So also super function. Well, super function, you can say is kind of useless in Python. We can talk about it. Like super function is same as copying function in the parent class to the function in the child class. So suppose I have a class P pen, and we can do this like define initial and super parentheses, kind of like a function, and then dot, and then just copy the initial function again. And what does it do? It's like when we can talk about using this example, the same, yeah. When I do P, I suppose it's an instance of this P class, dot receive some, then I get 30. It will first go into this class to look for the function receive some, and it looked into it. Oh, it's called super, and the functionality of super just be here. It helps you tracing back into the old function, and this can represent kind of like parent, I guess, like the parent of P. Uh, dot reception, and then it helps you connect and check back into the parent class, and you want to use the function. You want to use the function from the function with this name from the parent class, and this is what super do. Super is like helping you going back into the parent class, and then checking, oh, if you have this function, if you have one, you just execute this. So it's like um, when you have when you don't have something to change, um, you just write super and parentheses dot receive some, and it helps you to check it back into the uh, the parent class, and then help you execute this. So the super function does this, but why is that unnecessary though in Python? Um, use super function and the function name to pass the variables in the super. Oh, this is important. Like you're actually like using super premises to call your parent class, and then once you get that, you execute the function, and it will help you track that into the parent class. But you have to pass in the values. So yeah, why is that kind of unnecessary? Like I because the because why we use super functions like helping you checking back to your parent class, so that that's because I guess you don't want to make a change to the functions from the parent class, so that if you don't want to make a change to your parent class to the functions, like once you inherit the functions and member functions and attributes from your parent class. If you want to modify some, like make it different from the rest of the plants, you can do that. But if you don't want to actually want to make some changes, you don't have to. Like you can just don't write that function. Just skip the function in implementation. Yeah, you don't have to use the super function though. So, for example, um, for this one, I don't actually like I guess suppose I delete this line. Suppose I delete this line. I only have received some and collects some. Once I want to initialize the sunflower and then plant, if I can find this function, I will check it. I will check back to the parent class, like to find the function, to find the initial function. So you can use the constructor from your plant class. And another example is if I still keep this and I delete this function, and then when I want to do receive sum, if I cannot find the function in this sunflower class, I will check it back. The program will automatically check it back into your parent class, and then you see, oh, I got a function here, so I can use this function. So if you don't want to make a change, you just don't write, just keep the function re-implementation, because the program will help you check back into your parent class if you don't have the function in your class, in this class, the child class. Yeah. So this is more like the parent frame and the children frame, uh, which we talk about at the beginning of this class, this course. Like, if the program cannot find the attributes and member functions in the child class, you can search them again in the parent class. And if the parent class also inherit from other classes, you just go back and back until you hit the base class. Yeah. So if you still can't find it in the base class, you have an error, report an error. Yeah. So same as in parent frame, children frame. If you can't find the variable in the children frame, just go back to the parent frame to the base frame, the global frame. Yeah. So, but pseudo function, I guess, is important in C++. I guess you cannot skip that. It actually has something called virtual. Yeah. So you must have that virtual. Uh, so you can do polymorphism. Yeah. So string name representation. Yeah. So if you want to print out a string in Python terminal, we have two ways. How many ways? We have two ways to print that out. So I just type a equals this string and then type what's a will return this string, but with the quotation mark. And if you are not you're not typing a directly, you use the print a. It will help you to remove this quotation marks. So why is that? So why are they different, kind of? So um, so for the variable typing directly into the Python terminal, you will receive the representation of this variable inside the program, and it's aimed to be read by the program. So yeah, and also like you're doing typing the variable names directly. So you're using print function, you print out the variables, you will receive the string. You use the string type of this variable class. This is ended to be read by human. So it's a print A. So why is one read by program, one is one read by human? You have to know that like computer and human, they are very distinguished. They are very distinguished stuff. Yeah, distinct stuffs. And usually the more easier program reads, the harder for human to read them, and vice versa. Like suppose we are like for English, human can understand that once it studies English. Yeah, but for program, you'll find it hard to understand because usually program like at the very basic of program usually only have 0 and 1, and then assembly language kind of. Um, yeah, and what you do is like what programmers do is like to convert English into um, code. So usually like coding for people is kind of hard to understand. Yeah. So, but it can make it easier for program to understand though. Mhm. So, like these two types are aims to be read by the program. So for the representation, it's kind of like, oh, program cares about, not only cares about what's inside of this, what is stored. Like, let's say we have the app already called it, and yeah, and you have the string. It not only cares about uh the name of DVC. It also cares about maybe how many kind of like saying what is the data type of it, and uh, how many letters and spacing in this variable, things like that. Um, and for human, the only thing we care about is like what is stored, like what is stored there. Oh, it's just the name of DVC, the full name of DVC. But for the program, it cares about, oh, what's the data type, and how many letters out there, and what is that exactly, to help them fully. So once you going to use this stuff, you have all attributes for program to understand. Oh, you can do this, you can do this, you can do that. But for print, we only just read that, and then we see, oh, okay, we only cares about, oh, we only cares about the name. We don't care about, oh, whether it's a what data type is that. We don't care about that. So yeah. So for human, like for print function, you receive string, which is readable by human, and for representation, is readable by the program. Yeah. So like I have an example. For example, many people have their official names and nicknames. So usually, when they will use the preferred name, nickname as preferred name because it may make people easily remember their name, speak them out, and remember them. Um, like people usually only know about your first name, only know about your English name, so they can you can make it easier for them to understand, to remember you and to uh speak your name out. So next time they say hello to you, you say, "Oh, it's easy. Oh, I remember your nickname. It's easy to remember." So this is more like a string, like it is readable by human, kind of. Yeah. So it's easier to remember, easier to understand. But in the programming, like uh also in daily life, you don't use your nickname for government official papers, your school or something. Yeah, because you're using your ID, and what does the name on your ID should be your official name, although they may be hard to speak them out, may be hard for people to remember. But this is exactly your exact name, and that appears on your ID documents. So this is like in programming, this is like representation. Like I have to obviously for the program for the computer, oh, I have to remember you, I have to know what you are, things like that. This is more like representation of uh of the of the stuff. Yeah. So um representation are mostly different types of data or object, such as integers, strings, functions, lists, and class objects. Yeah. So so the print function unwraps the quotation marks or representation of the strings. Yeah, usually when you call print function, when you like, yeah, when you call print function like on the string, you have to remove the marks. Um, yeah, so it can be readable by human. The print function is to convert the representation type into the string type. And for representation, we can do a little bit example of it, I guess. It's like when you are creating an object, for example, for the PVC game, for the plant, it will return something like uh, some links, and then having like telling you this is an object and what is that exactly, and it will find it hard to remember and understand that. But computer use them to understand it. Yeah. So you just know, oh, the original representation of the data and object and also functions. Like they will have their stored address. They will have what the types they are. Like for example, functions, maybe a list, maybe an object, and usually those stuff, like where it is stored, where it appears in the main program or something, and their names, and you will find it hard to understand. This is the original representation. Yeah, when once you create it, but later then on, we can try to um, override the representation so that it can be readable by human. And also the print function, like for some object, you may also use print function. You may also print something like representation. I guess still hard to understand, but you can also override the string type, so it can make it easier to understand. Yeah. So the print function receives representations and display the content of representation and returns none. This is more like this is more like a projector. Yeah, suppose I'm having some kind of newspaper, school test paper, and I use a projector. It can be projected on the wall, and you will see there's nothing. Actually, there's no real stuff there. You may say this is only an image on the wall, but there's actually no stuff out there. So as is similar than in Python, the print function returns none, but it's actually displaying something to you, so you can see them and you can read them. So this is projector in real life, and projector is can be compared into the print function in Python. Yeah, I display something but return none. Projector is also display something, but there's nothing produced by projector though, only the image. And the image isn't a real object. Yeah. Just like and up so it's like a projector. There's something out there. You just you just make it like display on a large screen. Then you can read them from far away. And but there's only an image, it's not a real object. Yeah. So it's also like this. So we can try to override our string name representation. I guess for here, I have an example. Similar to real life, we can change representation and string name of the class object. Yeah. So want to write a class for United Kingdom country. So I actually design again again terminal to try executing again. So I'm using countries like UK, USA. Um, yeah, want to write class. I have a lot of class. I can show you later. So yeah, so I want to write a class for the UK, class United Kingdom, initialize self name capital, name equals name, capital is capital. Yeah, and then when you try to say, oh, create an instance of UK, so UK equals United Kingdom, the name is United Kingdom, and then the capital is London. So UK, and when you um when you just type UK out there, like we actually didn't change our representations and string name. It will be the changing process will be inside a new function. So changing representation is a function, and changing the string name is also a function. So should be at least 2 or 3 functions, but we only have 1 function. So I'm displaying the original representation and string name, yeah, of this class or instance. So I'm throwing that into the terminal with our printing function. So it should be displaying the original representation. So type UK, it will return, oh, this one. So it will tells you, oh, where it's stored, and this is the address, I guess. And also, this is the name called United Kingdom. Um, I guess the name or where the object, uh, what is this object? This object is a kind of the United Kingdom class, is from the United Kingdom class, and call this is an object. Yeah, this is the address. So this is the representation. Is readable by computer. It's not readable by human. Yeah. So how about I print this, print UK? Okay, it still be the same thing though. Yeah. So how about I change them? Change the representation. So for changing, I have define, and then I have two lower dash line underscore, and REPR is representation, and then self. I can just return self.name. So next time you call me, next time you call the instance, you'll return the name. Yeah, you return the name. So for example, so for in the UK, you return, I guess, the string of United Kingdom. Yeah. Oh, it's just, yeah. And also, when I want to print that, although I didn't actually change the representation, but I guess the string will be along with representation. Yeah, I'll return self dot name, also United Kingdom. So when you change the representation, you also change the string type. So yeah, the official name of a person is his or her default name. So which makes sense. Like the representation you can consider as the official name of this class or of this instance, United Kingdom, UK. And then okay, when I return when I use the representation, I'll be using the default name, but for the string is the nickname of this class of this object or this object. And since I don't have a nickname, I will use my default name, which is my official name, my representation instead. So if I'm changing representation, I'm changing my default name. So I don't have nickname though for right now. So I will use this name. Yeah. And then how about string type? This time I don't change representation, change string type. String type is his nickname, the nickname of UK. I return self.name. So, for example, for that, without a print function, I'll return this stuff. Also, what is this? Where it is stored? Like humans don't care about that. Only cares about what is your name. Like computer cares about, oh, where is it stored? What is that actually? Yeah. So this is different about program and human. They have their need or their different needs. So how about the nickname? Yeah. If I throw that into print function, how about the nickname UK? It return United Kingdom. Yeah. Okay. So a person can have a nickname. This is the official name. Official. So this is the nickname. Ah. So to override string name upon the representation. So suppose I have my original representation and string name, and I override my representation first, and then like I don't have to rewrite string like because the string name will be the same as the representation name. But however, I want to make representation and string name different, and they are all readable by human. So I will have my third. I'll just have representation and string together. Oh, string is two underscore and then str and then underscore. So it's like string. Yeah. So this time I return United Kingdom and then I will have the square bracket within the capital of this country. So I would say UK and then it return United Kingdom. How about print? United Kingdom, and then having London. London is the capital. So this time I will have some other more information included in my nickname. This is my official name. This is my nickname. So yeah. So okay. Um, okay, the last one is F string. So F string is more like let's see, what is the structure? String is like um I will have some other string and I will have variable one, maybe a variable two, variable three, etc. Maybe all other variables, and then I will have some string inside. Maybe there's a string or not. So what are the difference? So the string will be like for example, if I'm changing the name, let's say UK, I will be UKI, kind of U King. Yeah. And then capital will say LOND. Suppose I changing that. Suppose I changing that. And the string, for example, I will say name and then dot and then column and then capital and then dot dot. They are the strings. And this one are the variables. They are the variables using the bracket to enclose the variables. And then for this string, it will not change though. Although you may change the other stuff, like the string will not change. Like you always having this kind of name and then column, capital column. When you put that into other countries, you also having the same stuff. But however, the things in the variable may change. Things of variable may change. For example, I changed from UK to UKI and London to LOND capital. So if I pass in UK, so this if I pass like I have two example. So uh, I I have two this example. One is London. So one is London and UK. Another one is UKI and LOND. So I would say the string here and the string for the capital, they would not change. This will display name and then UK and then capital London. But for the second one, you still have the name and the capital same. But this time, for the variable one, it will change into UKI and LOND. Yeah. Well, because for the string they will not change in the fstring function, but fstring function allows some variables inside, such that each time variable can sometimes the variable will uh they change to store other stuff, and then for the fstring it will display the new stuff for this variable here. So you can um So you can have the so although you have the same name of variable, the variable out there, but variable may change, and then you can display other stuff other than only a fixed stuff. So they will be more flexible of displaying the name representation and string. And I have more here about um from the python.org about the f string. So this one is to display string type, and this one is to display representation, I guess. Yeah. So we can just know about it, and I guess it will be of use. Yeah. So, um, okay. The next page we are doing the practice about inheritance and polymorphism. Um, I have a base class called linear. Linear is like define. I have initialized this, and the size and empty. They they are already created well. And then all you have to do is like you use the codes to create a class called stack and class called queue. I remember that the linear structure of stack is LIFO, last in, first out. And for queue, it is FIFO, first in, first out. Okay, so yeah. And well, so I say the stack type, but actually I have linear here, so I will create in linear and queue as well, like create two stuff. And I'm doing the string representation of these two, so that you can see about the difference. So just copy that. So I will do class stack first. This time, I have to inherit from linear. So I can have this one though. Yeah, I can have define and super dot something. Like, but it's unnecessary though. Yeah, at least it's unnecessary in Python. And I can just do push and pop. Push is like self dot element, right? And just return. Let's see, just do something. Like self dot list. Self dot list. Dot hand hand. Define pop. That's nothing. Like I can return though. to return south down this down top. Check out if that's okay. So I have already created stack. So push it back and pop it out from the last one. So try stop stack is stack 1, 2, 3. Wait. Stack dot size. Like I couldn't find the stack dot size in my stack class. So what should I do? I will check out his parent class, because for linear, I actually copy all these the three defined functions into the stack, and the only thing I have to do is I have to add something new, or maybe just make a change in this one. Yeah. So if I can't find it here, I will just move it back into the linear, the parent class, and I find the size. Okay, so I will just execute this function. So for stack is okay, I guess. Stack dot pop and stack dot size. 2. Okay. So this time I would do 2. But this time I will inherit from stack. So I will instead use push to add my element and pop to delete my element. So for push, I guess I don't actually have to make a change, but I can play around with define in super function. So push self down self and then clean and super dot push element. I guess only for this, but you have to input the element. You have to pass in the element then. So define pop. This time I have to make difference though, because I'm popping the first one. So same thing, self.list equals to self.list, and then starting from 1. But you might want the first variable. So variable is self.list the 0 at the 0 index. So starting from 1. Okay, so return where? Okay. So check it out. Uh, UUE 1, 2, 3, and QUE the push. How about doing push? I push 4 into it. And push of size. Size become 4. Yeah. Like I couldn't find my size function in my Q class, and then I return to parent class stack. Oh, neither. So I will find it in linear. Okay, I find it. So just use it. Yeah. And the next one is pop. Say q dot pop. It'll pop out 1. So q dot pop is like uh moving the first one back, but I return the first one though. So okay. So I want to do string and representation of these two class. So I will use f string for q, and I don't use f string on stack. We can try to have a difference. Defined just representation, I guess. Well, we can check out what actually is q for the original representation. Like store in main program, and then q, this is an object of the class q. And how about stack? Stack, then just 1. Check it out. And stack, if I use print function, our print function, UUE, same thing. Yeah. and this time making slightly changes. Um, how about we doing some default ones, like change string, uh, stuff though, but this time just return. Oh, this time I return the list. Okay, so if I just do stack 1, 2, 3, will be the same stuff though, like string, but how about print? Okay, this time I will have 1, 2, 3 though. I return the list. So yeah, so this will be our default string, and I make some changes for this. I just change it to string. For Q, I will change the representation. Yeah. So self. So I will print something first. Print this is a stack. Yeah. Uh so print I think we have something cool like while len of uh hmm, can make something different. For I in self.list print uh uh bring the first one and a is 1 while a is less equal to length of this self dot this, then print self dot this. The um wait, I can check it out. Uh print stack. Oh, this is an infinite loop. I use an infinite loop. So yeah, so it will print out every member in the stack. So the first one is 1, first 2, the second one is 2, third one is 3. Yeah. So you can use string, like you can have any kind of stuff and any kind of idea inside the string and representation, and it's totally fine and it's of a lot of fun. So how about Q? I guess I have to do some space. Yeah. This time I do refine by EPR. And let's say uh I would say return. I can return an string. Yeah, why not? This is a Q. and then have self dot list, and then starting from self dot list and 0, and ending uh ending and same. I guess length might be better. With length of self length of self dot list. Cool. Invalid syntax. Wait, what? Okay. Cube. This time type in 456 for fun. So I'm doing representation. So I just throw that into the queue. Yeah, this is a Q456 with a length of 3. So how about having something different? 446, 445. And how's Q doing? Like as I said in the F string, like for the string part in the F string, it will not change. It will exist as it usually is. It stays the same forever. But for the stuff you are doing, the brackets using self dot list, length of self dot list, and this will change as you pass into different stuff. This will change. So it can make it more flexible when you are printing out the property and the attribute, the information of what you're creating. So this is very, very helpful, very useful. I can have something more fun. 10, 5. Yeah, so this time it's changing to length of 5 using this. Yeah. So hopefully you enjoy this lecture. At the very end, I want to introduce my game. So you see, I'm having a lot of stuff from the lecture. Yeah, so I'm creating a game about colonization. I have some countries. Let's say I will have the class empire, and then I have a lot of the behaviors that is presented here. Like I have a lot, such as say I have empire. So what the style of empire? So I have initialization of empire. I have the empire name, capital, how many colonies? Of course, it's in the list of colony, and money, integer, and do you have a permit or something like yes or no? And initially, like for the first time, because this is a board game, and I have some ships for each country, and which the first time when you want to put your ship, where you put your ship in your port, and then you initialize the place of your ship, and then uh you want to collect tests from your colleague, build factory in some of your colleague and things like that. Like when you actually learn the stuff of object-oriented programming of Python, you will usually um, creating games very easily, and it's a lot of fun. I highly recommend using the stuff you've learned from the lecture and try to make something creative, make something fun, and so that you can invite friends to play with you at home. Yeah. So initials a lot of stuff. What's the name, the capital, and calling, how much money is that? Like this is the same for each country, and how many ships out there, and the routes. Yeah. So how many resources I have? Wood, metal. This is in a dictionary. Do you remember? Like dictionary is like I have a key and I have some value. So I have all the data structures, some simple data structures that that are all included in the lectures up till here, from lecture 8, I guess. Yeah, I have this dictionary, data abstraction, and this is OOP. And next time we will talk about linked list. Linked list is not having here, but linked list is also very useful too. So uh like P1, P2, P3, like place one, place two, place three, and collecting tags. And I have a for loop here collecting, and yeah, I have building factory, like where which place and color, because I have two kinds. I have a red factory and a green factory. There are two kinds of factory. They are having different speed of producing stuff, and they have their functionalities and get resources from my colleague, like to check back, oh, this is a list comprehension. Yeah, list comprehension. You can check out in my YouTube channel because I upload some getting started video about this OOP, but at that time I didn't actually um debugging. So yeah, you can take a brief look at it, and build ship, where I build my ship, and free quality, which means when you go into my quality, you don't have to pay the parking fee. Like hopefully the DVC don't charge more for parking fee like free DVC. Yeah. So shutdown like I guess is shut down the factory though. Yeah, like you can check each place have a factory. If that has you can do shutdown, or otherwise yeah, exchange quality like uh exchange with who and what resource you want to exchange. You want to sell it or buy it, and how much money you do, and do you approve this transaction? If you approve, like usually when you have this function, you usually do approve. Yeah. So I want to show the inheritance part. I also have a tag who, how many ships for you, how many ships for them. Do you or he has a castle, and do you use oil, because you can burn ships with oil. The oil flows on the water and have some fire. And rob who, how many points do you use oil as well? If you succeed, how many money you have? Like what's the condition for you to have your money? You should have the license to rob. Yeah. JN for Robert. Uh, this is my inheritance part. I inherit an empire from empire into United Kingdom, and then I initialize it. Oh, I use a super function. Yeah, initialize as the same in empire. And then for UK, I can have 10 more per colony for like, what is this? This is like a specialist of a role or object. It's like this is very useful. So in like to use is using inheritance is very useful when you create a game, and then you have every specialist, because for every instance you don't have specialists for every instance, right? In the role you only have some certain groups of the instances. Yeah. I also have Russia, and oh, the Russia is like can spend less resource to build a ship or money. China is like getting more award for completing a trade route. Like I have to implement the trade trade behavior again by doing it all the things again and make some little changes like adding more money into the China's wallet. Uh, Japan, what's Japan doing? It do not. I guess it do not have to get approved by some places. When you enter the place, then you don't have to be approved by the owner of the port. But it's private. Like of course, you do not you do not need a license to rob. You don't have a license. You don't need to have a license to hunt ships on the sea. So yeah, United States build factories in a colony does not belong to United States. Like for other like in other words, like for other places, you have to build it. You have to have your colony, and then you can only build your colony upon the land. But for USA, like you just like in my game, you just build factory anywhere, without other people's permission or something. Yeah. So this is the specialist of US. Like for factory, because factory is related to resource. Like you build factory, you gain factory from you gain resource from the factory, and you build ships in factory something. And I also have class bank. Yeah. So I'm initializing all this stuff. This is only for tests. Yeah, only for testing. So I have so many British, like this is a list of colonies, a list of colonies, and I will have that. I'll have that in this one. I'll pass in the name, resource, other things are same for the beginning. And I have this. Oh, I make resource as an object. Yeah, as an OOP. So a list. And wow, I have so many. Oh, I have representation and string interpretation. Representation and string. Yeah. So, oh, I didn't talk about this. It's like when you want to let your string be like your representation, you can do this, but it's unnecessary though. Like as we saw, like representation is the default name of this object. String is the nickname. Since you don't have a nickname, you can only use your default name, which is the representation. So I'm initializing all the colonies. Also trade role. This is using data abstraction. I use a bunch of functions to create trading routes. We have starting point, like start point is a city, is a colony, and endpoint is also a colony. And then also profit. How much money is out there? If you finish that, you can get so many much money. If you rob it, you can get that much money as well. So, all right, this is it for today's lecture. I've shown the game. You guys learn OOP hard and try to make a game of yours. Yeah, this is actually just backend, like doing terminal and making decisions and doing calculations. So it does not have graphing though, but yeah, I guess that's enough for me though. I guess you can also create one like me, like helping executing game, such as like I'm actually interested in deciding a game. Or it's not designing game, it's like doing terminal, building up a terminal of a board game that's on the market. It's called Ticket to Ride. You can try making that because it's a very good example of implementing with a map or with a graph. Like you have trees, you may have find shortest path and the cost, like minimum cost spanning tree, things like that. It's very good example of doing research on the graphs on the map. Right, this is what I always want to do. To create a map and then try to traverse the graph. Of course, this is in DVC 210 or Berkeley 61B is about thinking about creating a graph. Okay, so this is it for today's lecture and hope you guys enjoy the rest of your week. All right, see you next week. We will talk about Linux.